Hello children, today our topic is acids, bases and salts. Okay, we have divided the substances occur in three parts, acids, bases and salts. First we are going to discuss acids. Acids are of two types, organic acids and other one is mineral acid. Organic acids, we also call them natural acids or natural acids. We get this from living things. Like it is present in plants and animals. Children, like citrus fruits, they contain citric acid. Milk contains lactic acid. Vinegar contains acetic acid. Tamarind contains tartaric acid. Proteins, they have amino acids. Tea, they have tannic acid. Tea have tannic acid. Apple, it has malic acid. And carbonated drinks, they have carbonic acids. Okay, so these are what natural acid, which I have told you just now. Now come to the mineral acid. Mineral acids are man-made acid. We manufacture them in the laboratories, like sulfuric acid, hydrochloric acid, nitric acid. These are the example of mineral acid. And here I told you organic acid, citric acid, so many acids I have told you. So they are the examples of organic acids. Now children, we are going to discuss types we have discussed. Now we are going to discuss acids can be concentrated or dilute. It depends on concentration. Okay. How we are going to change their concentration? By adding water. Suppose we are taking example of hydrochloric acid. Hydrochloric acid is consists of HCl. Okay, and it is made from hydrogen chloride gas. This is suppose gas. How are we going to make concentrated? We will take beaker. In this, 2 beaker. In this, I will take less water, and in this, I will take more water. And same amount of gas we are going to introduce in it. Okay, so in this same amount, suppose I have taken 50 ml gas, 50 ml in this 20 ml water, and 50 ml in 100 ml water. So in which the concentration of hydrochloric, this hydrogen chloride gas is more? In this 50 and water is 20. In this HCl, molecules of HCl 50, suppose number we are seeing 50. Okay, in 50 ml how many numbers are there? We don't know. Okay, here we have added. So here the number more molecules of water, because 100 ml water, and here 50 ml is this. So which one is more concentrated? More molecules are there. This one. More molecules and less water. So this is concentrated. Okay. In short form, we write it like this. This is concentrated hydrochloric acid, and this is diluted. Why diluted? More water molecules are diluted. Okay. Children, how are we going to check this acid? There are few substances, we call them indicators. Okay. Indicators, I am going to tell you about the indicators. Like one is litmus paper, available in the laboratories. Litmus paper are of two types. One is blue and other is red. This is blue litmus paper and this one is red. red litmus paper is for bases and blue is for acids. To check whether the substance is acidic or basic, we use this litmus paper. Okay, suppose we are having the substance which we do not know. I have taken in a test tube or beaker that substance. We are going to dip this paper. If it turns from blue to red, suppose I have dipped this, I have seen the upper portion which is not dipped, it is blue, and the lower portion which is dipped is turned red. Okay, means the substance is acid in nature. Okay, opposite, if we take in liquid in this any substance and we are dipping this red one, we will find the lower one is turned blue and the upper one which is in the air is still red. Means what? This is base. So these they tell this solution is base. So these things which tells us they change the color in acid and bases, we call them indicator. More indicators are there, like one I told you, litmus paper for acid and base. More indicate to find out the substances whether acidic or basic. We use other indicators like methyl orange and phenolphthalein. They changes their color with acid and bases. Okay. Methyl orange with acid, when a methyl orange turns red in acidic solution. It turns red in acidic solution and pale yellow in basic solution. Pale yellow in basic solution. Phenolphthalein is colorless in acidic and pink in basic. Basic solution. So these are indicators, by them we come to know whether the substance is acidic or basic in nature. Now children, we are going to discuss properties of acids. Very important properties of acids. Number one, they are sour in taste. Organic acid we can taste, but the mineral one we never taste because they are dangerous to taste. Second, they turn blue. Just now I told you, turn blue litmus to red. Next is they conduct electricity and they are corrosive in nature. What is the meaning of corrosive? Strong acid can destroy paper, cloth or wood, and they corrode metal such as iron and aluminum. That is why we do not store food item like which are acidic in nature in metallic containers. And they are also soluble in water. So these are the properties of acids. Okay. These are physical properties. Now we are coming to the chemical properties. Chemical means what kind of reaction do they give? When they react with metal. They give salt and hydrogen gas. Like magnesium is metal, and when acid react with metal, it gives, this is salt, and releases hydrogen gas. Salt and hydrogen gas, and they balance it. Another metal we are taking zinc. When react with sulfuric acid, it gives salt, zinc sulfate salt, and hydrogen gas. So it is clear, when acids react with metal, they get salt and hydrogen gas. Now reaction with carbonates. Reaction with carbonates. Carbonates, that means they contain CO3. Like I am writing here CaCO3. This is calcium carbonate. When it reacts with hydrochloric acid, it forms, this is metallic part and this is non-metallic part. These two react and give salt, CaCl2, and children, hydrogen is there, so they form water also. And carbonate is there, they form carbon dioxide. So these two things they always form when acid reacts with carbonates. Okay, carbonate and H together form water and carbon dioxide, and its metallic part and non-metallic part forms calcium chloride. One more reaction I am showing you. Na2CO3. This is sodium carbonate. When it reacts with sulfuric acid, it forms sodium sulfate. Na2SO4, and same water and carbon dioxide. Water and carbon dioxide. So it is always they form carbon dioxide and water when they react with carbonates. Okay. Now we are going to discuss their reaction with acid when acids react with bases. We also call it when acid reacts with bases, they always form salt and water. This reaction is also called neutralization reaction. Okay, they like both when they react, they neutralize their properties. Acids properties are neutralized by base, and bases property neutralized by acid, and then salt is formed and water. Like very common example is acid hydrochloric acid and sodium hydroxide. When they react, metal, non-metal, they together form salt. Okay, and hydrogen, and these two together they will form water. So this reaction is called neutralization reaction. Now children, we are going to discuss uses of acids. We have seen their chemical reaction, why acid reacts with base, when acid reacts with carbonates, and when acid reacts with metal. Now uses of acid, first we are going to discuss hydrochloric acid. It is used in oil industry to dissolve oil bearing rocks. They are used to purify salts and to remove scales that deposit in the boilers. In various industry, the process is known as descaling. And to make aquaresia. What is aquaresia, children? Aquaresia is the solution which we use to dissolve noble metal. How do we make? We take 3 parts of HCl and 1 part of nitric acid. So these two strong acids together they form aquaresia. It is used to dissolve noble metals. Now children, come to the sulfuric acid. Uses of sulfuric acid. Sulfuric acid is also called the king of acids. Very useful. King of acids. The uses: it is used in automobile batteries, to manufacture detergents, to manufacture drugs, plastics, paints, and so many other chemicals such as copper sulfate, Epsom salt. It is also used to manufacture fertilizers and also used in textile industries. Then our next is HNO. This is all nitric acid. This is called nitric acid. Same, it is used to manufacture fertilizers such as ammonium nitrate. It is used to manufacture explosive like TNT, dry nitrotoluene, and nitroglycerin. To prepare aqua regia, I told you already. To extract some metal from their ores, we also use nitric acid. To purify precious metals such as silver and gold, we also use nitric acids. Okay, children? Now come to the bases. Our acid part is over. Now come to the bases. Bases, some bases are strong, some bases are weak, like acids. Okay. Strong bases are sodium hydroxide, potassium hydroxide. Okay. And they are corrosive in nature, they can burn the skin. But some mild bases are there, weak bases. Okay. Weak bases, magnesium hydroxide, magnesium hydroxide, copper hydroxide, and ammonium hydroxide. All these are what? Weak bases. These are weak bases. Now properties of bases. Bases are hydroxide. These are hydroxide. OH tells these are, OH means they are hydroxide. Okay. They are soluble in water. Some bases, not all children. Some bases, they are soluble in water. They are called, are soluble in water. They are called alkalis. उनको हम लोग क्या कहते हैं? Alkalis. Okay. So these one statement is there that always confuse. So for that you have to make it clear. All bases are not alkalis. All bases are not alkalis. Why? Because all are not soluble in water, so we cannot say them. All bases are not alkalis, but we say all alkalis are bases. Okay. Now children, their reaction with acid I told you. Okay. Neutralization reaction. Already I told you neutralization reaction. One or two more reaction I am going to tell you. When bases react with acid, like I have taken bases NH4OH. When it reacts with acid, it gets ammonium chloride plus water. Okay, salt and water. Iron hydroxide, when react with nitric acid, it gives iron nitrate plus water, 3H2. Okay, so this is the reaction. Same manner, ammonium hydroxide also reacts with sulfuric acid. It gives ammonium sulfate and water. Now we are going to discuss uses of bases. Calcium hydroxide is commonly known as slaked lime. CaOH whole twice. We also call it slaked lime. The main uses of slaked lime is as a substitute for cement in low-cost construction, for whitewashing of buildings, to manufacture bleaching powder, and also for neutralizing acidity of soil. Sometimes soil become acidic because of excessive use of chemical fertilizers. Plants do not grow well in acidic soil. So this calcium hydroxide or quicklime, that is calcium oxide, they are added to the soil to neutralize the acid present in it. For treatment of wastewater, this acid is also used. Now next is sodium, uses of sodium hydroxide. Very important. Uses of sodium hydroxide. Very strong acid. Sodium hydroxide is commonly known as caustic soda. Okay, caustic soda, it is obtained commercially from concentrated salt water. Its main uses to manufacture soap. It is used to make soap, to manufacture many industrial chemicals such as sodium hypochlorite. It is used for cleaning the film, to manufacture paper, rayon in textile and medicine industry. Next we are going to talk about ammonium hydroxide for making fertilizers. Okay, for making fertilizers such as ammonium nitrate, to manufacture nylon, plastic dyes, etc. And ink remover is also to remove ink spots from clothes, like we use Vanish, ammonium hydroxide we use. Other bases which we use in our daily life, like antacid. Antacid, when we have acidity, children, you know, in our stomach, hydrochloric acid present in our stomach helps in digestion of food. Too much of acid causes indigestion and pain in stomach. So magnesium hydroxide or antacid, this is what magnesium hydroxide. Okay, magnesium hydroxide or antacid is we take, जिसको हम लोग जेलुसिल also we say, antacid we call it, or milk of magnesia. ठीक है, it, you know, this is base, it neutralizes the action of acid. For insect bite we also use what, baking soda, or we call that, or calamine solution. Calamine solution or baking soda, they are also bases. Now children, our next topic is preparation of salt. Preparation of salt. Already now all you are aware, salts are made by the combination of acid. When acid reacts with base, it gives salt and water. These salts we use, we make these salts. Common salt, all you know, we make this by this is one way to make prepare salt. Other way also I told you, when acids react with metals. When acid reacts with metal, they also give salt and hydrogen. This way also we make. And third, children, I am telling you, reaction between vegetable oil and caustic soda. By this method we can also produce salts. Now, how do we give the name to the salts? Okay, suppose I am telling you which acid we are using. Suppose I am using sulfuric acid. Okay, so sulfates, we write sulfates. I am telling you the name of the salt, like Na2SO4. Giving you example. Acid is sulfuric acid and base is sodium hydroxide. The salt we will get, the name of that salt is Na2SO4, is sodium sulfate. This is metal part and this is non-metallic part. The metal part we will take first and non-metallic parts name for later on. Okay, and then water is formed. Copper sulfate, when we are using, suppose sulfuric acid and copper hydroxide. Calcium carbonate when we are using carbonic acid and calcium hydroxide. Ammonium chloride when we are using ammonium hydroxide and hydrochloric acid. KNO3 like potassium nitrate we are using. By this we come to know the name of acid and name of base. This tells us the name of the base. Which base? Potassium hydroxide. Which acid we have used? Nitric acid. Okay. Properties of salt. Most salts are solid with high melting and boiling point. Most salts are soluble in water. Salt solution in water are good conductor of electric current. Now children, we are going to discuss their uses. Sodium chloride. I am writing down here. Sodium chloride, all you are aware now. It is stable salt. We use in food as a preservative in pickles, in curing meat and fish, in the manufacture of chemicals such as washing soda. And we also call it by which name? Common salt, table salt. Second salt I am going to discuss. Sodium bicarbonate. Okay. Sodium bicarbonate, other name is baking soda, chemical name is sodium bicarbonate. It is used in baking breads and cakes, in medicine as well as in fire extinguishing. Next is potassium nitrate. This is potassium nitrate. Okay, common name is nitrate. Common name is nitrate. It is used in the manufacture of gunpowder, in making fireworks, in glass industry and as a fertilizer. Next is very long name, potassium sulfate or potash alum we also call together. Eliminate and water molecules are there. Together we call it potash alum. Potash alum. And in Hindi or common name is fitkari. Okay, fitkari. It is used to purify water. Next is copper sulfate. Copper sulfate is blue powder. That is why we call it blue vitriol. Okay, blue vitriol as a fungicide, like the killing of fungi, and in electroplating, in cleaning, sanitation, laundry and in textile industry. Next is silver nitrate, AgNO3. We also call it silver nitrate. It is used to develop films in photography. So children, that's all. Thank you.